Yes. It'd be nice if you could do it this week, but... Okay, we're going to start in on Chapter 5 today, and Chapter 5 is going to focus on triangles. I don't think we have any proofs in this chapter, so that should be good. Yeah. We are going to learn after today. Today is something special with mid-segments. But after today, we're going to focus on something called points of concurrency. And points of concurrency is just a fancy way of saying a point where three different lines come together that have special attributes in the triangle. As an example, there's something called a median, which is from a vertex of a triangle that goes through the midpoint of the opposite side. Where all the medians come together is a point of concurrency. Where all the perpendicular bisectors come together is called a point of concurrency. And each point of concurrency actually has special things that you have to know. I'm going to give you a sheet with all of those things on it that you can fill out as we go. No, not really. No, we aren't going to be doing proofs. So this section is, we're learning about something called midsegments of a triangle. So if I have a triangle, a midsegment of a triangle connects two midpoints of the triangle. Remember how to find the midpoint of a segment? How do you do it? Yeah, it's the average of the x's, the average of the y's if you're in the coordinate plane. Okay, so, but if I know this segment is 10 units long, as an example, then the midpoint's going to be 5. Okay, and if I know this one's 6, the midpoint's going to be 3, or, you understand what I'm saying. So I'm going to find the midpoint here, and I'm going to draw my mid-segment. This is called a mid-segment, a segment that connects the midpoints of two sides of a triangle. Okay, so this mid-segment has some properties that are important to know, and this is the mid-segment theorem. The mid-segment is parallel to the side opposite it, and it's also half the distance. It's parallel and also half the distance. So I know if this segment here is 10, I can't write right now, but if this is 10, this mid-segment is 5 units. Okay, because it's going to be half the distance of the side opposite. Every triangle has 3 mid-segments, because if I go to the center, the midpoint of, I don't know why the board continues to do this even after he's replaced the projector. But if I draw, and I find the midpoint here, and I connect this point here to the midpoint somehow, this point, okay? It's hard to do with the mouse. But this segment, this midpoint here, okay, is parallel to this side. And it's half the distance of that side. Okay? And this segment here is parallel to this side, and it's half that distance. Can I get in the pattern here? Okay? And so I know this and this are the same unit, same length, because this is the midpoint. I know this and this are the same, and I know this and this are the same, right? And you can start to see, if these are parallel, that what I end up creating are 4 congruent triangles. Okay, so mid-segment, there's 3 of them. They are parallel to the side opposite them. Okay? And they're half the distance of the side opposite them. That's really, you're going to end up doing several problems using that information and that knowledge. Okay, as an example, if I told you that length was 3, what is this length? From here to here? 3. Yeah, they're parallel, so this whole length is 6. And this is the midpoint, so each one of these segments is 3. So you're going to be asked to do several problems related to those properties of midsegments in a triangle. Any questions on that? You want me to go through the textbook check? Everybody did okay on that one? All right. So as most chapters start, this will be the easiest section of the chapter, just understanding mid-segments. So it should go pretty quickly.
That's
That's
it?
it.
Yeah, I have a question.
Okay.
So say you're trying to find x, and your baseline of the triangle 8x minus 2, and your midline or your midsegment is 2x plus 1. How many find x?
Well, this mid-segment's half this list, this
Yeah,
length.
it's
So this is
exactly-
twice of this. So
Yeah.
multiply this by 2 and set it equal to that.
Oh, okay. Yeah, I tried to set them equal to each other, but 2x plus 1 divided by
They aren't equal to each other, though. It's half of that distance.
Yeah, I don't know how to find a little one.
That is it.